And in place surveying, the earth surface is assumed to be what? To be a flat surface.
So
And in the geodetic survey, the earth surface is taken to be a what? A curve or a curvilinear surface. Okay.
yes, sir.
And aside these two primary classification, there are other classification based on purposes or the type of instruments you are using or you want to use for your survey. Please, the person distracting this class should off his or her mic. So you may want to know the terrain of a place. You want to get the what we call digital terrain model of a place. And the type of survey to deploy in such a scenario is topographic survey. Okay, so based on the purpose, that leads you to carrying out topographic survey. Now, based on the type of instrument you use, your survey can also be classified based on that. As we can see, we treated chain surveying. Chain surveying came to be as a result of what? The type of instrument you are using for your measurement, which is chain. So that is why it is called chain surveying. The same thing with the compass surveying we treated in this course. It came to be as a result of the type of instrument you are using. You are using compass. So that is why it is tagged compass surveying. So we have other classifications of surveying, and it's maybe based on the purpose why you want to do that survey, or based on the type of instruments you are using. But don't forget the primary classification, which are the plane survey and geodetic survey. Now, we said, okay, let me ask this question this way. What is different between surveying and geomatics? The word surveying and the word geomatics, what is the difference? I told you in the course of this course that sometimes when I say surveying, I may use the word geomatics. Okay, so these two words are used interchangeably, at times, but there's a distinction between these two terms. Who can help us?
Yes, sir.
Yes.
I think you said that geomatic is the broad aspect of surveying, I think.
Yes. But you have not really answered my question. You are just attempting to answer the question. Is that all about the distinction between both?
The one I can remember.
Who is disturbing this class? Oh yeah, Michael, you want to say something? You want to help the class? Oh yeah, let's hear you.
So you said that geomatics involves a more broader aspect that includes data analysis and interpretation, while chain surveying is simply the measurement of distance using all the chain or tape. While surveying is the determination of position of or points above or beneath the earth surface. But geomatics is broader. It talks about the data analysis, the interpretation, and all that stuff.
Okay. You tried. Who else want to? I told you we are going to interact. So in this revision class, so who else want to add to what has been said so far on surveying and geomatics? Are the class reps here? Are they here?
Yes, sir. Yes, sir.
I hope I'm not speaking with the deputy assistant, I mean, the deputy class reps. Those are the people I've been seeing. The class reps are irresponsible. Your deputy has been one doing your work for you. And those are the people I've been seeing. So class reps, geophysics, geology. I want to hear you on this aspect that we're discussing now, surveying and geomatics. Let's hear you.
Good afternoon, sir. This is Ablet, a class rep for Germany.
You are class rep of
Geology, sir.
geology. Okay. Go ahead.
So, chain surveying, you can find out.
I did not say chain surveying. I don't know why. This is the second time I'm hearing someone saying chain surveying. I said distinction between surveying and geomatics.
Okay. So, in the first class they said geomatics is another word for surveying, and it's more like a broader
Yes.
aspect of surveying.
Yes.
That the name one.
I can't hear you again. No. Hello. Okay, not to waste much time on this segment, one of the major things I said about geomatics is that geomatics came to be as a result of advancements. Hello, please, off your mic. Is that Adejare still speaking? Off your mic. Your network is fluctuating, so we couldn't hear you again. Can you off your mic?
You mentioned the ESP.
Hello?
I said the ESP. Can you hear me?
Off your mic. We couldn't hear you again at a point in time, so don't worry. Just off your mic and listen. Who is showing us palm slippers here? Do I have grants permission for someone to share his screen here? Let me check the settings. Oh, I see. That's why you are misusing the opportunity.
Sometimes
Once I opened, let me share this. So can you hear me? Can you all hear me?
Yeah, we can hear you.
Okay, so now one of the things I said about geomatics is that as a result of advancements in technology, we have modification in surveying as a profession, and the rapid or the surge in technology wise led to the advancements in surveying profession, which brought about geomatics. Okay. And someone has said earlier on that I made mention of the fact that geomatics is a broader aspect of surveying, which is not limited just to determining relative position of points on the surface of the earth, beneath the surface of the earth, and above the surface of the earth, but also involve data processing, data query, data manipulation, data updating, and data interpretation. Okay, so these are the aspects that the geomatics has brought to bear. The surveying only deals with the data acquisition, which is only the determination of the position of points on the surface of the earth, beneath the surface of the earth, or above the surface of the earth, which can lead to production of map and charts, depending on the surface we are considering. All right, but geomatics has brought a lot of advancements, which is not limited to data acquisition, which is surveying, but you can now query the data, you can analyze the data, you can manipulate the data, you can query the data, and this came to be as a result of the various technology we now have in place to do all of those processes. All right. So that is why we now have geomatics. Okay. So that is that. So we also look at the reasons or the purposes of surveying or geomatics. Who can mention some of the reasons or purposes or benefits of surveying or geomatics? Oh yeah, let's talk now. You are wasting time, or I don't have much time with you. Or you want me to only talk alone? You don't want us to do interactive section, because I believe when we interact, the more then knowledge will be shared.
Good afternoon, sir.
Better, yes.
So
Good afternoon.
one importance of surveying, I remember, is for mapping Earth above and below the sea level.
Okay. Why do we, for purpose of mapping, to do what? Why do we need to map?
For measurement of land.
You're not still, making the point. You said for mapping. What is the benefit of mapping? Or the last statement you just made now, for measurement of land. Why do we need it? What is the benefit of doing measurement of land?
Oh, the lines are wobbling. I mean,
Hello?
So we can determine the size, shape, and magnetic fields of the Earth.
Yes, that is one of the purpose, determining the shape and size of the Earth and the external magnetic field. And why do we need all of that? You are just telling me the importance, but I want you to speak to those points you are making. Why do I need to know the size and shape of the Earth or the figure of the Earth? Why?
Due to human
Why?
and population and expansion.
Oh,
Because human population is
Because of human expansion and population growth.
okay, good.
So for
Good.
accurate data collection.
land value.
Okay. Okay.
For proper
Okay,
decision.
you have mentioned a few. So let's move ahead. What else do we discuss in the introduction? I think that's all. If I've not made the other things we discussed in the introduction, you have the platform now.
So applications of surveying.
Yes, thank you. Application of surveying. And I don't think I mentioned that surveying is ubiquitous. Did I make that statement in the introduction I did for you? That surveying or geomatic ubiquitous. What that statement means is that surveying has application in every aspect of life. Wherever you are, there's nowhere you cannot deploy surveying. There's nowhere you cannot apply surveying. Is it in agriculture? Is it in construction industry? Is it in telecommunication industry? Is it in oil and gas? Is it in banking? Is it in mining? And so on and so forth. So that is why we say surveying is ubiquitous. Is everywhere. You can apply it in every sector of the economy. All right. So I think I've mentioned some of the applications, and where we can apply surveying. So let's move on. Then from there, we look at linear measurements, and before we delve into the details of linear measurements, we highlighted about 5 measurements that we do in surveying. I think you have the material. So can someone highlight or outline those measurements for us aside the linear measurements I just made? Oh yeah, let's hurry up with that.
Horizontal angles.
Horizontal angles and
horizontal distances.
Horizontal distances.
Vertical distances.
Vertical distances. Please, who is that? Your mic. Oh yeah, let's continue to highlight those measurements.
Vertical angles.
Vertical angles. Okay, so we've mentioned the linear measurement, which is the horizontal distances, the vertical distances, then horizontal angles. Then we have the vertical angles. What else?
Slope distances.
Slope distances. Okay. So the vertical distances is also the height or the elevation. All right. So these are some of the measurements we carry out in surveying or geomatics. And we now look at the horizontal distance. For instance, if I don't have a tape or chain to do my horizontal distance, I can use what is called pacing. Pacing I'm not sure if I made mention of pacing for you. Did I? Hello?
Yes, you mentioned
No,
it.
sir.
You
So,
mentioned
so pacing, okay, I think I remember. I did talked about it. I did. So pacing, you pace with your leg and your distance, when you stretch your two legs apart, that is what we call pacing. The distance, between your leg, is actually about 80 centimeter. But a single pace is approximately to be 1 meter, which is 100 centimeter. So you can use pacing to estimate a distance. You want to measure distance from A to B, and you are not with any instruments. You can use pacing to estimate, that, okay, this distance should be about this figure or that by pacing. All right. So, but a human pacing is 80 centimeter, which is, I think, 0.8 meter. All right. So, but we approximately to be 1 meter. Okay. Now, instruments that we use for horizontal distance measurements. What are those instruments? I think I told you that we have direct and indirect measurements, especially when it comes to these distance measurements. The instrument that is common is tape. You draw your tape, you take your horizontal distance, okay, or you use your chain. There are other instruments, like the usage of tape or chain now is a direct measurement, but there are some instruments you can use to also get your distance measurements, but those instruments, will not give you the direct actual value. You have to now sit down and do a simple computation or calculation before you arrive at your figure or the magnitude of that distance. Unlike the use of tape or chain, that you can directly get your the magnitude of your length directly from them. E.g., odometer, there's an instrument called passometer, is in the material I gave to you. Then I also made mention of EDM instruments, electromagnetic distance measurements. Okay. And it uses the principle of your it uses your physics principle, electromagnetic radiation, So once the EDM instruments emanates electromagnetic radiation, there's a target that you place at the other end of the length you want to mention. Then the target reflects it back, to the EDM. So the radiation has a velocity. Okay. The velocity of that radiation, which is a light signal, and the distance to and fro, the time taken for the signal to go from the EDM instrument to where the target is, and it's reflected back to the EDM. So we have V equals to 2D over T. Okay, so now to compute your distance, now your distance will be the velocity multiplied by the time, then divided by 2. That will give you your distance. You know, if we take the velocity of that radiation as the speed of light, okay, then we know the time taken. I can compute my distance. So that is indirect measurement of distance. Okay, so that is that. Any other thing that we discuss as far as measurement is concerned that I have not made mention of?
I think
So
errors
errors in
and
survey.
calibration.
Okay, good. We discussed about errors, and I told you the importance of error in geomatics, that errors are very important in geomatics. That what we do to errors is that we minimize the effect of error in every of our measurements. And I told you that in determining error, we have to know the true measurements. Okay, true measurements of a quantity for you to obtain the error. That is, we must know the true error and the most probable. We must know the true measurements and the most probable measurements, because the difference between the true value of a quantity and the most probable value of that quantity is known as the error. Okay, and I've told you that in every of our measurements, we cannot have what is called error because we don't know the true value of any quantity we want to measure. We don't know the true value. It's only God that can give us true value of a particular quantity we want to mention. So what we do is that we have what we call MPV, which is the most probable value. Okay, most probable value. So since we can only obtain the most, or we can only have the most probable value of a particular quantity, you know, so what we can do is that what we refer as error, we have to be what we call the residual. And what is that residual? The difference between the most probable value and the measured value will give you the residual. Okay, so that is error. So, and that is residual. So I've explained what is the meaning of error, what is the meaning of residual, and I've also explained what is called the true value and the most probable value. Okay, now I also talked about accuracy and precision. Okay, and I told you that accuracy is the degree or nearness of a measured quantity to its what? To its true value. But since we don't actually have true value, the right word to say is to its most probable value. So that is accuracy. Then what is the precision now? We say that is the consistency of a set of measurements. If you are having a degree of consistency in a set of observation or measurements, then that measurement is precise. Okay, if I, for instance, now I want to mention the distance between A to B, and my first measurement is 10 meters. My second measurement of the same length is 10.01. The third measurement is 10.01. is 0.2. The third measurement is 9.99999. The fourth measurement is 10.003. The fifth measurement is 9.998. Can you see the consistency in the set of measurements of this length A to B? So these values may not be accurate, but they are consistent. Okay, so we say this measurement is precise. Okay, and I've told you that a measurement may be precise and may not be accurate. It is possible that it is precise and it may not be accurate. And sometimes when a measurement is accurate, okay, it is possible that it can also be precise. Okay. So when a measurement is precise, it is possible that it is not accurate. So try to know the circumstances where we can have one and we cannot have one, and we can also have both in the same measurements. So having talked about that, we look at some simple calculations, how we can minimize or remove error in our measurements, as far as linear measurement is concerned, where we are looking at the zag error, error due to tension in this applied to the string, error due to temperature. I hope you can still remember you have the materials. So you have to study those materials and know how to correct for errors in your linear measurements. When you use tape, it's possible your tape might have contrast or expand due to different factors. This may be the temperature, it may be the pressure, it may be error due to sag, and so on and so forth. So look at that materials. Before I move on to Shane surveying, we discussed about type of error and sources of error. So there are two different things, sources of error and types of error. So look at that, study that, and make sure that all of those things are well understood by you. So for Shane surveying, now I'm moving to Shane surveying. In Shane surveying, we talked about, okay, I think I've been the one talking. So let me go back because I said I would like it to be an interactive section. So in Shane surveying, what is Shane surveying? Let me ask you that question now. Oh yeah, let's respond now.
So chain surveying. So chain surveying is
my time. No,
the method of
I don't have time. I don't, because we still all have to cover, things a lot, but I will just be highlighting those points for you. I won't go into details as if I'm teaching it. Now, Shane surveying, we said that in Shane surveying is the simplest form of surveying in which we only deal with linear measurements, only linear, that is distance measurements. Okay, we don't do any other measurement aside the distance measurement. That is why it's the simplest form of surveying. Okay, and we also said the the principle of chain surveying is what? The principle of chain surveying is what? Oh, yeah,
Triangulation.
good triangulations, where you create series of triangles on the field or the sites where you want to carry out your chain surveying, and that helps you with your chain surveying processes. Okay, now let me ask this question. We have 3 operations in chain surveying that are run simultaneously. We do those 3 things together in chain surveying. Let's list those 3 operations.
Sir, chaining,
Yes, Shani.
ranging and offsetting.
Yes, ranging and offsetting. And I'm very sure you know the meaning of those 3. Okay, but we are doing revision, so I hope you know the meaning of those 3 operations: chaining, ranging, and offsetting. We do them simultaneously as we do chain surveying. Now we have under the offsets, we have 2 types of offsets. Can you mention that those 2 types for me? Offsets.
Perpendicular offset and oblique offset.
Good.
Perpendicular and oblique offset.
Yes, perpendicular offset and the oblique offsets. Okay. Now let's look at some of the terminologies in chain surveying. Let's highlight those terminologies. Oh yeah. Let me hear you. I want to hear the class now. Terminologies in chain surveying.
Sir, survey stations.
Survey
stations.
Survey stations, yes, good.
Survey lines.
Survey line, good.
Main stations.
Main station, okay.
Baseline.
Yes, baseline, thank you. Very important term. Baseline, okay.
Check line or proof line.
Check line. And what?
Ranging.
No, ranging is not a terminology. It's part of the operations, which we've talked about earlier.
So tie stations.
Tie stations, go tie stations. Now, all this terminology, I hope you know them. You can define them, you can identify them when you see them, in a diagram. All right. So, is anything I've not mentioned as far as chain surveying is concerned?
Procedures for field work.
Hello?
Instruments.
Okay, let me move to compass surveying. Now, okay, there's something I didn't mention. The conditions. You guys are not reading your book, so I even remember 2 things now that have
instruments too.
Now, I've not mentioned what is it called now? We said the principle of chain surveying is triangulation. Okay. There's what we call well-conditioned triangle. Well-conditioned triangle. So what is the meaning of well-conditioned triangle?
When no angle in the triangle is less than 30 degrees or greater than 120.
I can't hear you. You said what?
I said when no angle in a triangle is less than 30 degrees or greater than 120.
Okay, good. So that is a well-conditioned triangle. And when you are creating triangles in chain surveying, those triangles must be a well-conditioned triangles. Okay. So what else I've not mentioned? Okay. Before, what are the conditions that must be met before you deploy chain surveying on the field? What are some of the conditions that must be met? Or I can just deploy chain surveying as I wish.
The area must not
Hello?
be undulating. The area must, I said the area must not be undulating. It must be plain without many trees or obstructions.
Okay. Good. Any other conditions?
The main line
The
must
area should,
be level ground.
Area must be,
it shouldn't be too wide, sir.
I can't hear you. Your network is working. So I hope you know the conditions. So I think that is all. Okay. And in chain surveying, I think I gave it as an assignment. We have different types of chain. We have the surveyor's chain, we have the engineer's chain, we have the Gunter's chain, and I said go and study the properties of those chain. Okay, I hope you've done so. Then what else did I? Okay, difference between compass, no, Gunter's chain and engineer chain. Okay, okay. So I think I've mentioned all now. Yes. So let's move to another topic. Compass surveying. Compass surveying, we said in compass surveying, we deal with measurement of distance and bearing. Okay. We use chain or tape for the distance measurements, and the bearing we use what? We use compass. Okay. For compass